Hello everyone and welcome to Mathematics. So this video will focus on chapter 3, integration, and let's aim ourselves to learn two things from this video. Alright, so I'll let you have a few seconds to go through this question first. Alright, so for part A, we have a curve and a line that intersects at point B and point O, as you can see in diagram 4. So now we need to find the area of a shaded region. So when you look at this question, you have to ask yourself, are we using x-axis or y-axis as our reference axis? This means that when we are finding the areas, are we finding the areas which are bounded by the x-axis or the y-axis? Because sometimes one of the ways may be easier to help us find the area. Okay, so here I'll give you a hint. You can look at the equation of this curve, this part, which is y squared. So if you see there is y squared, you can use the y-axis. For x-axis, it will be x squared. Okay, so for now, in this case, we use y-axis. So there's another thing we need to note is that whether left side and right side of the y-axis do we have area of shaded region. So for this case, we only have for the right side, correct? So here we don't have much of a concern, but if let's say we have another area, which is let's say here, this we take note, because when we are calculating from the right side, the area on the right side, it will be positive. But if we are calculating here, which is the left side of the y-axis, the answer it will give negative. So for both of these areas, the red one and the black one, we need to calculate separately. Okay, because one of it will produce a negative answer, one will produce a positive answer. So for this left side, we need to add a modulus to change the answer from negative to positive. Okay, but for this case, we don't need to. Okay, so we don't need to consider this case. But if you would like to see this kind of cases, you can refer to one of the videos that we discussed before, so I'll put the link here. Okay? Alright, so now finding the area of shaded region, we have two ways actually. So one is big area minus the unimportant small parts, or the other way is big area into parts. Okay, so the first way, if we go back to this question, our big area would be the area that is covered by this curve and the y-axis. Okay, so this is our big area. So our unimportant small area would be this part, but will be a bit difficult because there's no formula that we can straight away find the area of this part. Okay, so now we go to the second way. Split the area into parts. So we can split this shaded region into two parts. One is here, this triangle, and the other part would be this, the one above. This is actually the area under the curve. So what is area under the curve? Okay, so if you view this thing from the right side, this area is actually under this curve, under this blue curve, if you look from the right side. Okay, so this is what we know as area under the curve. Alright, so now to find the area of shaded region, we need these two areas. So for the area of triangle, we can use the triangle formula, which is 1 over 2 times base times height. So the length of the height and the base, we can use the coordinates from point B, which is 5, 5. So 5, 5 means the length here is 5, here is also 5 as well. Right, so here we just multiply 2 5s. And to find the area under the curve, we need to use integration. Okay, so let's put the integral here at the end. At the end of the integral, we need to add the y, because we use y-axis as our reference axis. So if outside is y, inside would be x, meaning we need to integrate x. So going back to the equation of the curve, we have x equals to 6y minus y squared. So we can substitute this x to be 6y minus y squared. And for the limits, we need to refer to the y-axis. So the lowest y-axis value is actually 5, and the highest y value would be, according to this intercept, is 6. Okay, so it will be 5 to 6. Right, so now to simplify this, we just need to calculate this value and we need to integrate this. Alright, so remember when we integrate, make sure we add 1 to the power. So here would be 1 plus 1, so here would be y to the power of 2, and we need to divide the new power. Same goes to y squared. And we need to substitute the value 6 and the values 5 into this, and we minus these two values together. Right, so our answer would be that 1 over 6 units squared. Alright, so for part B, we have a new diagram, means we have a new line and a new curve, and we need to find the volume generated when this shaded region is rotated 360 degrees around the x-axis. So a good thing for volume questions is that we don't need to specify which axis we need to use because it will be given, unlike the previous question. Alright, so to find the volume generated, so let's view this question as we are finding area of shaded region first. From a 3D view, we change it to a 2D view first. Okay, so to find the area of shaded region for this question, we can use the first way, big area minus the small unimportant areas. Okay, so the big area would be here. So this is actually the area under the curve. Okay, so if you view it below here, this area is actually under this curve. So here would be area under the curve, and we can minus out this white color area, which is actually a triangle. So to find the area of shaded region, we can minus these two areas. Right, so now let's view this into a 3D view. We imagine these two areas are rotating around the x-axis. Okay, so for this region, if we want to find the area, we integrate. For volume, same thing as well. Okay, so to find the volume, we just need to integrate, but the formula will be slightly different. Okay, so later we'll explain this. So for the triangle, if we rotate around the x-axis, as you can see in this video, you can see that it becomes a cone. Right, so if we draw this cone in this diagram 5, it will be something like this. So here will be our radius, here will be our height. Right, so here triangle will become a cone in the 3D view. So we need to use the formula for the cone, which is 1 over 3 pi r squared h. Right, so the formula would be we need to add pi, unlike the previous question, and we need to add an integral, so the end of the integral would be dx because we are rotating around the x-axis. So means here we need to integrate y squared, okay, y squared instead of y. So make sure you to know this. So the y squared, we can find it from the curve's equation. So you can move -4 to the other side. So here we will obtain y squared equals to x plus 4. So we can change this y squared to x plus 4. Alright, and for the limits, we need to view it from the x-axis. So the lowest x-axis value would be 0, which is here, and the maximum x value would be here, which is, according to this point, is 12. Okay, so we need to integrate from 0 to 12. And for the cone's volume, be 1 over 3 pi. So for the r, we can view it from this coordinate as this point as well. So for according to the y coordinate is 4, so our radius would be 4. And for the height, according to the point for this point's x coordinate, here would be 12 as well. Right, so now, like the previous question, we integrate this and we just need to calculate this. Alright, so one thing to note is that for the 4, when we integrate, we need to add an x. Okay, so the rest of the things will be similar to the previous question. So our final answer would be 56 pi units cubed. And with that, we have completed today's question. Alright, so here's the take-home points for this video. So the first point would be when we're finding areas, we have these two ways. So this is the way for part A, this is the way for part B. And to let you all know that for this chapter, you will be asked to find these four areas. Area under the curve, triangle, rectangle, and trapezium. And for the second point, which is to find the volumes, make sure to view it into a 2D perspective first, which means we need to find the area first. Then once we have the areas, we translate it into 3D, which means we rotate all the areas around the axis. So if we found in 2D, we found triangle, so if we rotate, it will become a cone. For rectangle, when rotating, it will become a cylinder. Alright, so here's the answer scheme for this question, and hopefully you have learned something new from this video. So if you feel this video is beneficial to you, please leave a like, subscribe, and share. So thank you so much for watching. I'll see y'all in the next one. Bye bye.